Hello, this is Gang Lee at Yonsei University in South Korea. It is my great pleasure to give you a talk at the BIM Era Conference 2020. Today, I'm going to talk about how BIM has been adopted and implemented in South Korea, particularly from 2008 to 2020, and share the lessons we've learned during this period. Before I talk about how BIM has been implemented in Korea, let me briefly talk about the history of BIM in general first. Then I explain how BIM has been implemented in South Korea, focusing on the period from 2008 up until today. My research team has surveyed the adoption of BIM in South Korea every 2 years since 2008. I'll share some of the results focusing on the changes during the last 5 years using several major technology adoption models. Not all BIM projects are successful. I'll briefly describe the outcomes of the case studies that my research team has conducted and shared some of the secrets of the successful BIM projects. And I'll conclude the presentation by summarizing and sharing the lessons learned. A brief history of BIM. Probably many of you are already familiar with the history of BIM, yet the reason I want to talk about this is that Chuck Eastman, who's known as the father of BIM, passed away this month. So how did Chuck Eastman get the title as the father of BIM? There are quite a few theories about the origin of BIM, but a commonly accepted theory is Chuck Eastman, who used to teach at Georgia Tech, was the first one who defined BIM as we use today. In 1974, Professor Eastman defined a system called Building Description System, BDS, and developed a prototype. He said that BDS can derive sections, plans, isometrics, or perspectives from the same description of elements, and any change of arrangements would have to be made only once for all future drawings to be updated. And also, the system can conduct any type of quantitative analysis, including cost estimation and material quantity takeoff. It will provide a single integrated database for visual and quantitative analysis, including automated building code checking and scheduling and materials ordering. As you can see, the descriptions about BDS were very close to what we see as BIM today, and this gave Chuck Eastman the title as the father of BIM. In 1989, the Netherlands published the first National BIM Guide. This is the first written document which used the term BIM, Building Information Model, as we use today. And in 1992, G.A. van Nederveen published the first academic paper which used the term BIM. In 1997, Frank Gehry used BIM to design and build the Guggenheim Museum Bilbao, which was perceived as impossible to build at the time. People knew that the technology Frank Gehry deployed was different from the traditional AEC practice and technology, and wondered what that was and how to code the technology. In 2003, major CAD vendors including Autodesk, Bentley, and Graphisoft published a white paper on the next generation CAD technology and called the technology BIM. However, there were many debates about what the term should be. BIM was not the single term that was accepted from the beginning. For example, many people still use VDC, Virtual Design and Construction, to mean BIM and claim that there are minor differences between the terms BIM and VDC. Through an online debate entitled The Great Debate, hosted by Jerry Laislin in 2003, people started accepting the term BIM as a standard term. In 2005, the first large BIM workshop was hosted by Georgia Tech. Many core people related to BIM, including Chuck Eastman, Bert Heiko at Stanford, and Phil Bernstein at Autodesk, joined the workshop. As the outcome of the workshop, the first edition of the BIM Handbook was published in 2008, which was followed by the second edition in 2011 and by the third edition in 2018. It was my honor to join as one of the authors of the third edition of the BIM Handbook. BIM adoption in South Korea from 2008 to 2020. My research team asked practitioners in South Korea when their first BIM project was. According to the survey results, the number of BIM users continuously increased, and some of the earliest BIM projects in Korea dated back to the late 1990s. So there were BIM projects in South Korea before 2008. Then what is the significance of year 2008 in the history of BIM in South Korea? There were quite a few small and medium-sized BIM seminars in the mid-2000s in South Korea. But it wasn't up until 2008 when Korea had the first large BIM forum which had over 1,000 audiences. Also in 2008, I, as the chief editor, started publishing a BIM magazine named The BIM. The BIM is still being published by Building Smart Korea. After the first issue in 2008, 22 issues have been published. By looking at the changes in the topics of the BIM, you can tell how BIM has evolved in Korea. For the first 3 or 4 years, the issues focused on what BIM was. For the next couple of years, the issues focused on the application examples and status of BIM adoption in Korea. After that period, the issues focused more on the advanced use of BIM. Also in 2008, several government organizations in South Korea announced a project using BIM. In 2009, the city of Seoul announced that Dongdaemun Design Park, DDP, would be designed and built using BIM. Zaharit, one of the great architects of the century, won the competition. There were many interesting challenges, which were reported in articles, papers, and as a case study in the third edition of the BIM Handbook. We cannot talk about the BIM adoption in Korea without talking about the BIM roadmap of the Ministry of Land, Infrastructure and Transport, MOLIT. In 2008 or 9, MOLIT announced that it would mandate BIM from 2016 after gradually increasing the scope of BIM mandates from 2010. Currently, all public projects over $50 million are asked to use BIM in Korea. Many public organizations in Korea published a BIM roadmap, and they claim that they would reach a matured level of BIM sometime between 2020 and 2030. Here's a collection of major BIM roadmaps around the world. These BIM roadmap collections were created as part of the Railway BIM 2030 roadmap, which my research team created for MOLIT and the Korea Rail Network Authority. If you're interested in these diagrams, you can download the Railway BIM 2030 roadmap from BIG yonsei.ac.kr/railbim, or just Google Railway BIM 2030 roadmap. The Korean government is also investing a lot of money, about $95 million per year, on BIM-related research projects. In 2006, 7, and 8, there was only one BIM research project per year, but today we have over 150 BIM projects, research projects per year. BIM surveys in South Korea from 2016 to 2020. My research team has been conducting BIM adoption surveys every 2 years since 2008, and the results were published in the BIM magazine published by Building Smart Korea, and also in the Smart Market Report series in 2012 and 2014. The 2014 Smart Market Report compares the BIM adoption status in Korea and Brazil. At the time, Brazil had a higher implementation level of BIM than South Korea. We used several technology adoption models in the survey to understand the status of BIM adoption in Korea. The first model is the hype cycle model. The hype cycle model was developed by an American business consulting firm, Gartner, to describe the maturity of emerging technologies, including the dot-com or the internet boom in the 1990s. What the hype cycle claims is that people's expectations rapidly go up to create a hype or a bubble when a new emerging technology is introduced and becomes matured through a rapid downfall. It describes the technology adoption process in 5 phases: innovation trigger, peak of inflated expectations, trough of disillusionment, slope of alignment, and plateau of productivity. Survey results indicated that the Korean construction industry is moving from the peak of inflated expectations to trough of disillusionment. The second model we used to track the level of BIM adoption on a macro level was the BIM utilization level model, the BUL model. My research team developed this model to categorize the level of BIM adoption by how people utilize BIM in their projects. The BUL model is composed of 6 phases. The first phase is the visual BIM phase. In this phase, BIM is used mostly for marketing or visual communication purposes. It is also referred to as BIM wash. In the mid and late 2000s, this was the most common way of using BIM in South Korea. Then people quickly learned a better way of using BIM and started using BIM for design review by converting 2D drawings into a BIM model. We refer to this phase as the 2D to 3D conversion BIM. People got even smarter and started using BIM and 2D drawings together. BIM for geometrically complex areas and 2D drawings for simple areas. Practitioners in South Korea refer to this phase as the 2-track BIM phase. This became the most common way of using BIM in South Korea and is still the most prevalent way of using BIM. I think this is also the most common way of using BIM in many countries. Another common way of using BIM today in South Korea is referred to as fully integrated BIM, where all the major project participants create and use BIM models during a project. A new trend is to use BIM based on the lean manufacturing philosophy. Examples are off-site construction, lean management method, and robotic construction integrated with BIM. We refer to this phase as lean BIM. We are seeing more and more projects which adopted the lean BIM approach, and we believe that this will be a common practice in 2020s. The ultimate goal of BIM is to make informed decisions and not to repeat the same mistake. To do so, many companies started compiling big data and are investing a lot of money on AI and data analytics. This trend will become dominant in 2030s when the data and software application for helping us making informed decisions become available. We refer to this phase as the intelligent BIM or AI BIM phase. More details on the BUL model can be found in the 3rd edition of the BIM Handbook. Our survey showed that, as mentioned earlier, the most common way of using BIM in South Korea was 2-track BIM, but the percentage of integrated BIM projects gradually increased. From this trend, we can predict that by 2022, integrated BIM will be the most common way of using BIM in South Korea. We are also seeing not many, but some projects conducted using lean BIM or intelligent BIM approaches. Another index that we used was the Net Promoter Score. Frederick Reichelt, a business strategist, published a paper in the Harvard Business Review in 2003. The paper made him famous. The paper challenges you by asking if you can ask just one question to know the potential growth of a company, what should be the question? Actually, you have already heard of the question many times. Can you guess what the question is? The question is, would you recommend this company or product to the others? We refer to this question as the referer intent question. Frederick Reichelt proposed the Net Promoter Score (NPS) to measure the referer intent. The NPS categorizes the respondents who gave 9 or 10 points as the promoters and the ones who gave less than 6 points as detractors. The NPS is measured by subtracting the percentage of detractors from the percentage of promoters. In our survey, we used the NPS to understand the potential growth of BIM. The NPS values of BIM users were 21% point in 2016, 9% point in 2018, and 25% in 2020. Although there were some fluctuations, the numbers were all positive. From 2018, we started measuring the NPS of non-BIM users. Non-BIM users gave minus NPS values to the referer intent question. We knew that non-BIM users' attitude toward BIM was not positive, but didn't expect that the NPS values of non-BIM users would be this low. In general, non-BIM users perceive the benefits of BIM lower than BIM users. Probably that's the reason that they do not use BIM. There is also a major difference between non-BIM users and BIM users in the perception about the obstacles to BIM adoption. Non-BIM users perceive that BIM software-related issues, such as limitations of BIM software functionality and libraries or the price of software applications, are the major obstacles to BIM adoption. Even among BIM users, there are also differences in the perception about BIM depending on the level of BIM expertise. Novice BIM users tend to perceive BIM software problems are the main obstacles to BIM adoption, just like non-BIM users. Expert BIM users tend to perceive higher benefits of using BIM than novice BIM users. Also, expert BIM users think that the permit process, social and temporal issues are more a problem than BIM software-related issues in BIM adoption. This means that you have to be not just a BIM user, but an expert BIM user to appreciate the benefits of BIM. BIM case studies. We know that just using BIM in a project does not guarantee the success of the project. I'll share some of the secrets of successful BIM projects, focusing on their collaboration and coordination strategies. The first case study that I'd like to introduce explores how different BIM coordination and information sharing strategies impact the BIM coordination productivity. In this case study, 2 MEP experts were employed for the coordination of a very complex pharmaceutical building project using BIM. The first coordinator took what we refer to as the parallel or concurrent coordination strategy. He asked the project participants to work on their modules in parallel. This parallel coordination strategy left many errors even after several cycles of BIM coordination, as shown in this image. As a result, the construction of the area the first coordinator was in charge of was delayed. On the other hand, the second coordinator asked project participants not to work at the same time, but to wait until the modules of the subcontracting work with high constraints were finished. We refer to this approach as the sequential coordination strategy. The case study shows that the sequential coordination strategy was 3 times faster than the parallel strategy, and also left only a small number of manageable errors as shown in this diagram. We developed the Design Exchange Matrix Analysis (DMA) method based on the graph theory to analyze the characteristics of information sharing and exchange strategies deployed by the 2 coordinators. The result shows that the sequential strategy could increase the information sharing and equality among project participants, and that it could also reduce the workload of a BIM coordinator. Another way to put it is that if you can increase the information sharing rate among project participants, you are likely to increase the coordination productivity. Through another case study, we learned that the reduction of design errors did not mean reduction of total construction cost. Through this case study, we learned that to reduce the total cost of construction, Subcontractors' proactive involvement in design conflict resolution and value engineering process during the pre-construction phase was the key. We proposed a two-step subcontracting method to facilitate such a subcontractor's involvement. The case study shows that the proposed two-step subcontracting method could reduce 10% of the total construction cost. I won't be able to share all the knowledge gained through the case studies we've conducted today, but I hope that I have another chance to talk about them in more detail in the future. Lessons learned. For the past 12 years, we learned many things about BIM. Among them, I'd like to conclude this presentation by pointing out some of the core lessons. The first lesson is that the more you know, the more you see. The ones who are using BIM and using it well perceive more benefits than those who don't use BIM or poorly using BIM. So the lesson is, if you want to benefit from BIM, be an expert user. There are still many issues to resolve, but software limitations or the adoption fee should not be the major obstacles. By BIM experts, I don't simply mean people who can use BIM tools well. To benefit from BIM, you should have good understanding of how different BIM implementation strategies affect the whole project. This is more important than just being a BIM tool expert. The second lesson is that Rome was not built in a day. BIM experts, including Chuck Eastman and others, predicted that BIM would reach the mature stage around 2018, but I guess we're not there yet. One reason is that the industry is not transformed as fast as we expected. Another reason is that we are finding more and better ways of using BIM every year and every day. So there are more things to catch up with every day. In 2010, Penn State categorized BIM uses into 25 types. In 2020, the University of Wuppertal in Germany analyzed the BIM uses, and this list includes more than 300 BIM uses. So there are still a lot of things to learn about BIM, and it will take much longer to reach the mature stage than we expected. The adoption and implementation of BIM was so slow that many people perceived that there was no change between now and 10 years ago in terms of how people use BIM. We know that's not true. Although the adoption speed is slow, we've been steadily adopted BIM. I believe that we as an industry as a whole eventually will win the race against the low productivity, fragmentation, safety, and other issues as far as we don't give up BIM adoption in the middle. As the final statement, I'd like to make a proposal. In 2014, a global BIM survey was conducted. Let's conduct another global BIM survey in 2022, which is 2 years from now, and see how we are doing, not in a competitive way, but as a way to learn from each other. Obrigado. Thank you.